Okay, recording.
My thesis is titled Human Factors Analysis of Automated Planning Technologies for Human-Robot Teaming. The vision of humans and robots working together to accomplish complex team tasks is driving much of the current area of research in the area of autonomous teamwork. As the robots are becoming more and more capable, they can handle increasingly complex tasks, and they can even handle highly uncertain environments. But however, the current capabilities of the robots are still insufficient to handle such a dynamic environment, and they are not able to perform independently, robustly, or efficiently all alone. So in these scenarios, the robots can still accomplish those tasks with the help of the human assistance, as the human capabilities often complement the robot capabilities in such situations. And this is also true for the other scenarios wherein the human controller cannot always do certain tasks that the robot can do. Consider a urban search and rescue scenario where the robotic agent can perform situation assessment in disastrous and hazardous areas, whereas the human controller cannot by himself go inside such environments. So there is a compelling need for the human-robot teams in such scenarios. And given the need, they need to be effective in various task settings, so that we kind of need to bring such robot teams to be closer to human teams. So when we analyzed and looked upon human teams, we had some interesting results which are as follows, wherein the human agents in such teams seem to plan for themselves, wherein they by themselves had a planning running on. And also they also seem to proactively support the other human teammate, wherein by proactive support I mean the human counterpart doesn't need to specifically ask for any help, wherein the other teammate can infer the current goal and can take actions as necessary. The human teams has proved to be the agents who had planning and proactive support had proved a higher teaming performance, but the question in hand is if you are going to incorporate the connection that we got through the automated planning technology to human robot team, would this still hold? So obviously incorporating an automated planner would enable autonomy in the robot's end. It will also enable the robot to reason directly on the high-level goal, and it supports in decision making rather than just issuing low-level motion commands. And the planning part of the automated planning technology would allow the agent to plan for itself, and the proactive support component mainly uses the goal and intent recognition module to infer the current goals of the human teammate and take proactive actions so as to help them. However, the question in hand is, would that lead to higher teaming performance as we saw with the human teams? So there are several factors that could affect the teaming performance, which is the side effect of automation. While with automation, there is a positive effect as well as a negative effect. The negative effect may be due to the fact of trust factor, wherein the humans may feel uncomfortable at such a robot autonomy and cannot trust or invest the autonomy with the robotic agent, as well as there will be a loss of situational awareness on the human end, since he might not always be having a good idea on what the robot is doing or what the current situation of the robot is. So automation by itself has some negative influence. So this could eventually affect the teaming performance. So the overview or the question that I aim to evaluate through my thesis is that is automated planning for robots preferred in human-robot teams? And the second question that I aim to investigate through human factor analysis is proactive support from the robot agent in a team is preferred. Going on, there are two kinds of human-robot teams given the physical distance between the human and the robot. One is kind of a remote human-robot team where the robotic agent and the human commander are physically separated and they are not closely coordinated. They have communication constraints. Whereas another one is proximal, where in this case both the agents tend to be in the same physical workspace and they closely coordinate to achieve a shared objective, like collaborative manufacturing is an example. And all of my research primarily focuses only on the remote human-robot teaming aspects. Moving on, and here is my first study, wherein the question in hand is automated planning for a robot preferred in human-robot teams. To evaluate this question, I kind of use two kinds of remote human robot teams. One is the supervised team wherein, in this case, the human himself computes a plan for the robot acting inside the environment, and the robot does not have a planner in it. The human delivers the plan to the robot either as a low-level motion command or as a task or a sub-task which the robot can then plan for. In a peer-to-peer team, the robot in itself has a planning component incorporated so that it can generally plan for itself given an initial state and a complete environment and a goal that it needs to achieve. It basically uses the planner component to generate a plan, compute a plan, given an initial state and the agent's actions. So given these two types of teams, this automated planning, which is that the robot in the peer-to-peer team is preferred, is the question in hand. So there are several factors that can potentially reduce the effectiveness of human-robot team. One is the trust factor. By trust I mean, are the humans completely willing to accept the automation that is provided to the remote robot? And the other one is information asymmetry. There exists information asymmetry in such scenarios through task incompleteness. The robot in such environments can not always model the task to its planner because some of the perceptual and other tasks can be modeled or incorporated very well only by the human agents. So I perform a human factor analysis to validate the effectiveness of the automated planning in human robot teams.